Hello, everyone. I'm happy to see you here on a Wednesday afternoon. I hope you're enjoying reInvent so far and having an amazing time. I've enjoyed the many conversations I've had with customers this week, and I've learned a lot. My name is Ramesh Kumar, and I lead product and solutions for AWS Snow Family, a family of secure and rugged devices that our customers use for their edge computing workloads. So today, for the first 30 minutes or so, Danny Wei, Snow's principal engineer, and I will walk you through how the AWS Snow Family can help you meet your edge computing workloads. Then we'll have Mike Roberts from Hypergiant join us, and he's going to walk you through how his company is using Snowball Edge for robotic combat vehicles. At the end, we'll leave some time for any questions you may have. Okay, let's start. So first, I'll provide you with an overview of the continuum of AWS services from the cloud to the edge. I'll dive deeper into the AWS Snow Family and provide you with an overview of AWS Snowcone and AWS Snowball Edge, the two main Snow services. Then Danny will join us, and he'll walk you through the edge computing capabilities for the AWS Snow Family, and he'll provide you with a real customer example. After that, Mike Roberts will join us, and he'll talk you through how Hypergiant is using AWS Snowball Edge. I think you'll find this very interesting. Towards the end, I'll come back up on stage and talk about how the Snow Family can help customers use multiple Snow devices for complex edge computing workloads and highly available deployments. At the end, we'll open it up for any questions you may have. We have a lot to cover, so let me jump in. In Amazon, everything we do starts with working backwards from understanding our customers' needs and their pain points. We've talked to a lot of customers, and here is what they're telling us. They want to extend the AWS capabilities for AWS Cloud infrastructure, services, and tooling for monitoring and management to wherever they need to run their operations. This gives customers the flexibility to run their applications in the AWS Cloud, in on-premises locations such as their data centers, or at the edge. And they need to do so because there's a set of applications that need to run at the edge for low latency requirements, to meet data sovereignty requirements, or for local content and data processing for the data and content that's generated and captured at those edge locations. And when you look at these applications at the edge, there's kind of two types of these applications. There's born in the edge applications. So these are applications that have been residing in the on-premises locations. They're developed, tested, and run at the edge. And oftentimes these applications are suited, optimized, developed for running in disconnected environments or environments where there is no consistent network connectivity. Could be intermittent network connectivity or limited network connectivity. And then you have applications that are native to the cloud. They're born in the cloud. And now maybe there's a new use case for our customers where there is data being generated at the edge. So they need to now deploy and run these applications from the cloud to the edge so that they can capture the data, process the data, and make intelligent decisions, AI-based decisions, or these low latency decisions at the edge locations. Our customers want to modernize these applications at the edge. They want to use the same AWS services and APIs that they use in the cloud so that they get the same business value, they get the benefits, they get more insights into their data. And it allows them to run a set of applications or similar applications in the cloud and at the edge locations. Our customers have also told us that they face many challenges in running their operations at the edge. They face challenges in deploying equipment and applications to those edge locations, in maintaining and updating their devices and software and applications, and scaling those applications. And today we'll talk about how AWS meets customers' requirements for running their applications at the edge, computing applications at the edge, and resolves those challenges and the pain points they face today. So when you look at that continuum of AWS services from the cloud to the edge, you've got the AWS Cloud, and then we've helped extend the infrastructure, services, API, tooling of the AWS Cloud to edge locations so customers can run their applications wherever they need it. On the left side of this graphic, you see the AWS Cloud that is suitable for most of our customers' applications. And when customers run their applications in the AWS Cloud, they get the full benefit of all the 200 plus AWS services, the resiliency, durability, and reliability of multi-AZ processing, and the online monitoring and management that AWS provides. Then as you move towards the right side of the graphic, you see the edge locations where customers can run their applications. You see AWS local zones, which is an extension of AWS infrastructure and services closer to the customer, in the metropolitan centers or sites closer to the customer, so the customers can run their applications with low latencies and maintain their data residency requirements. You have AWS Wavelength, which is AWS infrastructure and services deployed and integrated in a communication service provider's network. So you can keep that tight latency for your mobile application with your 4G, 5G network and the applications integrated with AWS. In the middle of the graphic, you see AWS Outposts, which is deployment of AWS infrastructure and services at the customer's facility, at their on-premises locations, can be their data center or other conditioned environment. And as you move further to the right, that's where you see the AWS Snow Family with AWS Snowcone and AWS Snowball Edge. And customers can use the Snow devices to run their applications in rugged edge locations. And by the rugged edge, we essentially mean unconditioned environments outside a data center. It could be a factory floor in a manufacturing facility. It could be a private 5G network that's deployed outside a data center. It could also mean mobile environments. Think about running your applications and operations while in motion, in an autonomous vehicle, in an ADAS test vehicle, in a disaster recovery truck, in a cruise line ship or a Navy ship, or in commercial or military aircraft. Customers also use the Snow devices to run their applications in DDIL environments. The term DDIL originates from the US Defense Department, and it describes a set of environments that are disconnected, so no network connectivity, or they have intermittent network connectivity. Think about a cruise line ship that has intermittent network connectivity with satellites, or limited network connectivity. Think about a factory floor or a healthcare facility that's in a remote location. And in these environments, the customers need their applications to run independent of AWS for long periods of time. And if the further right side of the graphic, you see smart devices. That could be smart industrial equipment, it could be warehouse robots, or it could be smart city devices that are suitable for AWS IoT services, like IoT Greengrass, IoT Sitewise Edge, for use with industrial sensors and equipment, and IoT RoboMaker. I'll dive deeper into the AWS Snow family. So what are the customer requirements for running their applications and operations in rugged edge locations and DDIL environments? We talked about how the customers need to run their applications at the edge for low latency processing, to meet data sovereignty requirements, or for local data and content processing. In many of these edge locations, customers need to deploy their edge devices and applications in environments where there's a lot of shock and vibration. Think about a factory floor with robots, motors, and other industrial equipment, or an oil and gas platform. Think about environments in motion, an autonomous vehicle, a truck, a plane, or a ship, or any vehicle. And customers also need to run their applications in environments where they do not have consistent network connectivity. It could be limited low bandwidth network connectivity, such as a remote location for a factory floor or a healthcare facility. It could have intermittent network connectivity through a satellite communication, or it could be completely disconnected. There may be other environments where the customer does have network connectivity, but it's cost prohibitive to move all their data to the cloud for processing. Or maybe they have to maintain their applications and data at the edge for local regulations and local laws. And in these environments, customers need the AWS services running on those edge devices and their applications to run independent of AWS for long periods of time so that they can operate in these DDIL environments. So let's talk about how the AWS Snow Family can help customers achieve their needs and run applications in these rugged edge locations and DDIL environments. So the AWS Snow Family has two main services, AWS Snowcone and AWS Snowball Edge. These two services are available in multiple service configurations depending on the compute capability and storage capacity available to our customers. Customers use these Snow devices as an IoT hub to capture data that's generated at those edge locations. Could be data generated by sensors, industrial equipment, warehouse robots, drones, media and entertainment cameras, security cameras, or medical equipment. The data is stored on the Snow devices, and the data is analyzed and processed. And when customers do have a network connectivity, they can either transfer the data stored on the Snow devices or the results of the analysis to their data lake in AWS. Customers use the Snow devices for image analysis and video analytics for the content that's generated and captured at those edge locations. And we have customers who are running ML inference applications for predictive analytics type use cases on the Snow devices. They develop and train their ML models in the AWS Cloud, and when it's ready, they can deploy those ML models on the Snow devices for ML inference. And for all these use cases, customers can run their applications independent of AWS for long periods of time. And when they have connectivity to AWS, they can transfer the data to AWS, they can update the software and resources, their applications on the devices, they can do online monitoring and management. So Snowball Edge is a suitcase-sized, secure, and rugged device. It's portable, it weighs less than 50 pounds, and can be carried by a single person. Security is very important for our customers when they run their operations at those edge locations. Customers are storing data and their applications on Snowball Edge and other Snow devices in environments in unconditioned environments where they may not have any operator. Snowball Edge is very secure. All the data stored on Snowball Edge is encrypted using 256-bit keys that are selected by our customers. The encryption keys themselves are not stored on the Snowball Edge device for added protection. Snowball Edge is physically secure and is tamper-evident. You can use Snowball Edge in environments where there's a lot of shock and vibration. Again, examples of a factory floor, oil and gas platform, or in a vehicle during motion. Snowball Edge is MIL standard compliant, so our defense customers use it for tactical edge deployments. And there's multiple configurations of the Snowball Edge device, and customers can get up to 104 vCPU in compute, up to 210 terabytes of NVMe storage, and up to 100 gigabits per second of networking throughput on a Snowball Edge device. Our customers have told us that they want to run even more complicated applications on Snowball Edge for running private 5G in a single device, or for doing ML inference or data analytics. So recently, in October 2022, we announced an enhanced version of Snowball Edge, which has double the compute capability. Customers can now get up to 104 vCPUs and 416 gigabyte of RAM memory. We've also enhanced our storage capability on Snowball Edge to be all NVMe storage. This provides greater protection for operation and shock and vibration. It also improves the performance of reading and writing data on the Snowball Edge device. To support the more complex workloads, we've now introduced larger EC2 instances on the Snowball Edge device with support for 64 vCPUs and 96 vCPU. Many of our customers deploy Snowball Edge for their compute applications for at least 1 year, but in many cases, our telco, defense, and our factory manufacturing customers want to deploy Snowball Edge for at least 3 years, and we've even seen more than 5 years at their edge locations. And to support these customer needs, we offer 1-year service pricing that is renewable multiple times. We do not sell the Snowball Edge device. We provide it as a service. And what that means is, after the end of 1 year, if the customer wants to update their device, they can simply send the device back and order the next device. It also means if the device gets damaged, it's AWS's device that got damaged, and we will upgrade your device in the field. We also have customers who use Snowball Edge for just a few months for some short workloads, and we provide monthly rental pricing for use of Snowball Edge. If you have large volume deployments, you can work with your sales teams to get discounted volume-based pricing. So just in the short period of time since October 2022, we've been positively surprised by the customer adoption for this new enhanced version of Snowball Edge. We have customers using the Snowball Edge with the 104 vCPU for private 5G network deployments, where they're able to install and run an entire private 5G network in a box, where 5G RAN, 5G core, and multi-access edge computing can run on a single device. Customers are using the enhanced Snowball Edge for ML inference, for data that's generated and captured at the edge, and for data analytics. The disaster recovery use cases, they're using Snowball Edge for disaster recovery in the back of a truck, where images and data, the IoT data captured in those disaster zones, can be quickly analyzed with low latency and real time on the Snowball Edge devices, helping first responders in the field. We also see automotive customers use Snowball Edge, and we've also seen our defense customers using Snowball Edge for tactical edge deployments. AWS Snowcone is an ultra-portable, secure, and rugged device that customers can use for their edge computing workloads and also to capture data at the edge and move that data to the AWS Cloud. Snowcone weighs less than 5 pounds or about 2 kilos. And with its small form factor, customers can carry Snowcone in their backpack. They can use it with a drone or use it in an autonomous vehicle. Just like Snowball Edge, Snowcone is very secure. All the data stored on Snowcone is encrypted using 256-bit encryption keys. The keys are not stored on the Snowcone device for added protection. The device is physically secure and is tamper-evident. Customers use Snowcone to capture data that's generated in the edge by drones, cameras, robots, and autonomous vehicles. You can store up to 14 terabytes of data in a single Snowcone device. Once the data is stored, you can run some analytics and analysis with the 2 vCPU that's available. And you can bring that data and the results of the analysis to AWS in 2 ways. If you have connectivity to the network, you can use data sync, AWS data sync on Snowcone to transfer the data online. Or you can simply ship the Snowcone device back to us, and we'll import the data to your data lake. For example, automotive customers typically order 3 to 5 Snowcone devices per test vehicle. And as they fill their data up from their test drives, they can simply ship it back to us and use the next device for the next day. You can also use Snowcone in space. We work with our partner Axiom and NASA to test Snowcone from a very rigorous testing over security, shock, vibration, EMI. And earlier this year, Snowcone was launched on a NASA rocket and deployed in the International Space Station. Researchers are using Snowcone today to capture images in space and run image analysis and machine learning. We talked about how customers want to use the same AWS services and API in the cloud and in the edge. The Snow devices support a select set of AWS services for compute, storage, IoT, data analytics, and machine learning. And when we say an AWS service is supported on a Snow device, both the data plane and the control plane of the service runs on the Snow device. This allows our customers to run their application independent of AWS for long periods of time so that they can operate in those DDIL environments. For legacy applications, customers can develop their VMs in EC2 in AWS Cloud and run them on EC2 compatible APIs on the Snow devices. For container workloads, you can develop your workloads on EKS in the AWS Cloud and run it on EKS distro on the AWS Snow devices, and you can manage your cluster using EKS anywhere on Snow. You can run your applications as Lambda functions on the Snow devices. For IoT use cases, you can use IoT Greengrass, IoT Sitewise Edge, supported on the Snow devices. For machine learning, you can develop and train your ML models on AWS SageMaker in the AWS Cloud, and then run it on SageMaker Edge, supported on the Snow devices. You can use data sync for transferring data between Snow devices at the edge location and the AWS Cloud. For storage, support EBS-compatible API for block storage, and we support S3-compatible API on the Snow devices for object storage. And you can use IAM on the Snow devices to manage differing level of access by different operators and system administrators for the Snow devices at the edge locations. And for this next section, Danny's going to join us on stage.
Okay, so how does the Snow family of edge devices actually enable edge compute use cases? The core is the ability to run compute instances, i.e. virtual machines, on Snow devices in denied, disrupted, intermittent, and limited connectivity environments. All other compute models, such as Kubernetes or containers, build on top of these instances running on Snow devices. Snow devices provide a local control plane, which includes a local EC2 API-compatible endpoint, allowing you to use standard AWS and EC2 constructs to run instance-based applications. While the instance types on Snow devices are unique to Snow and vary between our device types, Snowball Edge instance types roughly correspond to the M5 instance family with similar vCPU to memory ratios. To run instances, we need Amazon Machine Images, or AMIs. There are two main methods for getting these AMIs onto Snow devices. The first is to export a compatible AMI from the region when ordering the Snow devices. The second is to import a VM image directly onto Snow devices that are already in the field. So the process for getting an AMI provisioned when ordering a device involves first selecting an AMI that you want to base off of from the AWS Marketplace. Today, we officially support Amazon Linux 2, Ubuntu Server, CentOS, and Windows Server. Bring your own license versions. You will need to subscribe to the Marketplace offering so that you can customize the AMI for your use case. You will launch an instance from the Marketplace offering in the region for this customization, installing any apps, doing any configuration necessary, and adding any additional credentials. Note that we do support injecting new SSH credentials when launching instances on Snow devices in the field, similar to when you launch EC2 instances in the region. Also note that your data, including AMIs, are always encrypted on Snow devices. After you've done customization and configuring of your instance, you can create a new AMI from that instance via either the Create Image EC2 API or through the AWS console by right-clicking on your running instance and selecting Create Image from the context menu. Once that is completed, your AMIs will now be available for selection when you're ordering a Snow device. Now, what if you need to add a new AMIs after you've received your device? There are generally two main use cases here. One is you've made updates to your AMIs in region, and now you want to push those updated images to your in-field Snow devices. The second is you have images that you are already using in your your existing virtualization infrastructure that you want to run on Snow devices. For the first, you can use AWS's VM import-export functionality to export an AMI as a raw disk image that you can then download. You can do so via the Export Image EC2 API and using the raw disk image format parameter. After you've downloaded your raw image from the region, you now upload that image to your Snow device via the S3 API compatible endpoint that the device provides or through our AWS Ops Hub GUI client. Remember that Snow devices are designed to operate in DDIL environments, so this method provides you a mechanism that allows you to get your AMIs from the region onto Snow devices that are in the field without actually having to connect these Snow devices to AWS directly. Finally, you import the image as a snapshot on the device via the Import Snapshot API, and then register a snapshot as an AMI via the Register Image API that the local EC2 API compatible endpoint provides. Now, for the second option, if you have images that you want to import onto the Snow devices from your existing infrastructure, you need to export them as raw disk image format. And then you would proceed to do the same steps of upload, import, and registering the AMI on the device itself. If you want to import images that are of a different format, such as VMware's VMDK format, then there are tools such as QEMU Image that can help you convert the VMDK format to a raw format. So while instances and virtual machines are great and the foundation for pretty much all compute workloads nowadays we have more modern compute models. The one that we hear the most about is, of course, containers and container orchestration with Kubernetes. With instances, you have ultimate flexibility, and we have customers who run their container workloads or Kubernetes workloads on top of the EC2 instances that run on Snow, using either EKS distro or their own Kubernetes distributions. To make this easier for customers, we are building in EKS Anywhere integration onto the Snow platform, simplifying the process of setting up, maintaining, and operating an EKS cluster that is fully compatible with AWS EKS in region, allowing simple portability of your containerized applications between the cloud and the edge. The EKSA integration consists of providing an AMI for a control instance that you launch on a Snow device, which is then used to create an EKS cluster, automatically launching and configuring and managing the required worker node instances. This can be either on a single Snow device or across multiple Snow devices to provide fault tolerance and high availability. EKSA enables the automation of cluster management, making it simple to manage through EKS-provided tooling. Similar to EKSA on-prem, this will also support EKS Connector, which will allow you to leverage the EKS console in region as a single pane of glass to view all your EKS clusters, including those deployed to Snow devices when there is connectivity. Another really cool feature that Snow provides is direct networking interfaces. With direct networking interface, Snow devices can support multicast streams, routing, load balancing, and other networking use cases by enabling instances on Snow devices to have direct access to an external network. By providing instances with layer 2 network access without any intermediary translation or filtering, customers gain increased flexibility over the network configuration of their Snow devices, along with improved network performance, enabling use cases that were previously not possible. To use this feature, customers can create a direct network interface associated with one of the Snow device's physical network interfaces and then attach it to a running instance on the Snow device. Each direct network interface can be assigned a VLAN tag, and customers can optionally customize the MAC address. Multiple direct network interfaces can be associated with a single physical network interface and with a single instance, enabling use cases that require network segmentation. This can all be done through the Snowball Edge CLI locally on the Snow devices. Now, a fun fact about Snow is that Snow began as a data transfer offering, allowing customers to physically ship data from on-prem to AWS, and we continue to support and improve on that foundation. It fits well into the Snow Edge compute model because when you really think about data transfer, it's really just a service or use case running on top of edge compute. Building on the data transfer functionality, we provide an S3 API-compatible object storage service on Snowball Edge devices, allowing you to develop applications that utilize the most prevalent of object APIs for storage. In addition to this, we provide integration with AWS Data Sync, allowing you to move data to and from AWS in region when the Snow devices have connectivity. Finally, we continue to provide our offline data transfer capabilities, where when you ship your device back to AWS, the data that you store on the device is automatically ingested into AWS S3 in the region. The final capability I want to highlight is remote management functionality. While Snow devices are designed for DDIL environments and use cases and provide a local control plane in addition to the local data plane, we recognize that in many use cases, customers will have some level of connectivity. With remote management, when there is connectivity, customers can unlock, reboot, and monitor device status via the region using AWS Ops Hub, allowing customers to easily manage multiple disparate Snow deployments. This provides a simple, unified interface for both local edge management when disconnected and remote edge management when connected. Now, let's go ahead and put some of this functionality together by looking at an example and use case that we're exploring with an internal customer. And this showcases a very common pattern that we're seeing at the edge. Let's say you are running a large e-commerce website that has its own last-mile fulfillment network, and you want to optimize your delivery routes. You have a set of distribution centers, but some of them may have limited connectivity or bandwidth. You have a fleet of delivery vehicles that you've outfitted with sensors and cameras that are collecting data, such as traffic conditions when doing deliveries. You want to use this data to optimize path and route planning, such as avoiding areas of high congestion or routing around construction. So what might a solution for this look like? You can take Snowball Edge devices and you can deploy them to your distribution centers. As your vehicles come back from their deliveries, you can gather the data they've collected by uploading it to the Snowball Edge's S3 API-compatible object store. You can then use Snowball Edge's numerous compute capabilities, such as instances or containers or SageMaker Neo, et cetera, that can then filter and process that data and recommend timely local decisions around route and path optimizations. You can then upload an interesting subset of that data that you use to make those local decisions to the region via the limited connectivity that is on site. And then finally, periodically, when the devices fill up with data, you can ship the Snowball Edge devices back to AWS to import the full data set into AWS for further analytics across all of your distribution centers. And kind of this is an architectural diagram that kind of highlights what this looks like. And when you really think about it, this is a very common edge use case that we see. You gather data at the edge, a rugged edge. You filter and process that data locally to make timely decisions. You send a thinned out data set or the interesting data set to the cloud through a possibly low bandwidth online connection. And then periodically, you want to send the full data set via Snow's offline data transfer mechanisms for archival purposes or for large-scale processing of the full combined data set. So now that we've covered kind of this use case, let's go over a real use case from Hypergiant.
All right, so my name is Michael Roberts. I am the Chief Technology Officer of Hypergiant, just like the slide says. Hypergiant provides mission operations and decision support software and services to space, defense, and critical infrastructure. So there's three players in the story that I'm going to tell you this afternoon. One of them is our friends at the Snow team, who are providing the capabilities provided by the Snowball Edge device, the considerable capabilities. I won't go into that. They've covered it very eloquently here. I will add that our president of space and defense calls the Snowball a box of awesome. And after a year's worth of experience with it, I can concur with that. The second player is the United States Army. The US Army has a program called the Robotic Combat Vehicle. And that RCV program is split into three types, light, medium, and heavy, referring to the size and capabilities of the respective vehicles. The image here is a prototype of a light vehicle. And the work that I'm going to talk to you about really applies to all three. but a lot of what we've been doing has been with the light group. The third piece in the puzzle is a software platform that we provide called CommandCenter. It's basically a mission operations and decision support platform. They say never to read from your slides, but I'm going to go ahead and read from my slide. CommandCenter is a real-time, highly performant, intelligent insights and actions platform designed for AI. CommandCenter supports multiple data formats and courses of action for a variety of specific use cases customized to your operational needs. By the way, our marketing department says hi. What that means to me is that CommandCenter provides you a 360 view of your data, more than 360 because it provides it in multiple layers. It brings your data together visually. It draws attention to important elements within it. It provides you projections and recommendations, and it allows you in context to pull additional relevant data in order to make decisions. It's all about making decisions. You've probably seen slides like this a few times in your life, but we'll go ahead and go through it again. We've got a bunch of different kinds of data coming in, multimodal, across different spheres of action. We use machine learning and analytics to make sense of that data. And then finally, we visualize it so we can provide insights directly to the end user, which in this case is the warfighter. I won't get into great detail on these components. I will not read this slide. But I did want to point out that we've got a lot under the hood besides just the visual portion of CommandCenter. There's elements pertaining to the training and deployment of machine learning models and data security, and then also kind of an overall management tool. So this is the scenario that we're talking about here. These are the RCVs here out on the edge. Now, the RCVs are robotic. I emphasize that they are not autonomous. So they have operators in vehicles that are behind the lines, but close by. And they communicate with the RCVs. So the mission of the RCVs is primarily scouting, reconnaissance, and then support of manned vehicles. So they're out there. There's a crew of 2 operators per RCV. So in this case, there'd be 6 people in this vehicle, 2 to operate the vehicle, and then 4 to operate the respective 2 RCVs here. So we've got 2 of those vehicles here in the field. We've got 4 RCVs. And then we have a single snowball or snowball collection processing that data. So the snowball aggregates the data and hosts the applications at the company and the battalion level. The RCVs download their data to the snowball whenever they have an opportunity to. Remember earlier in Ramesh's presentation, he mentioned DDIL, when you're in an environment where your communications could be disrupted or interrupted or limited for some other reason. That's going to be very common in a combat situation, obviously. And then finally, urgent data is sent back to the continental United States for use by military or intelligence, whoever needs to know. So this is the scenario that we're working on with RCV. We're working through the Army Futures Lab with the Army Applications Lab, or Army Futures Command, Army Applications Lab. And they're based in Austin as well as Hypergiant, so it's convenient for us. So this is kind of what an operator would see in CommandCenter operating those vehicles. So, whoops, how do I go back? Red button, there we go. Yeah, so here we've got our 4 RCVs, and you can see that 2 of them have been compromised in some way, one of them severely. And then back here, the things with the little Wi-Fi symbols on them are the control vehicles. So the operator has observed that there's a problem with two of the vehicles. One of them has a severe problem with the track failure potentially being imminent. So they can call up more information on that vehicle and what the specific failure mode is. They can pull up schematics and specifications. They can identify which parts specifically are going to be the problem. And then they can see a recommendation right here. In this case, the damage is severe enough that you would want to withdraw that vehicle. Sustainment is essentially the opposite of attrition. It's the effort to keep as many vehicles in the field operating as efficiently as you possibly can, as opposed to losing them. And if we have machine learning models that can do predictive maintenance effectively on the vehicles while they're in the field, then that could be the difference between keeping that vehicle in the field and losing it unexpectedly. So those previous two images are essentially mock-ups of what we want to put into CommandCenter for this application. The RCV vehicles don't exist yet. They're prototypes. We're working with the Army to define what the control capabilities are from our end. We've got 2 snowballs on order for this application. We've been running 3 snowballs for another branch of the military. I cannot talk to you about that use case, but I can show you a demo that is cleared for public consumption. And this is kind of an overview of some of the capabilities of CommandCenter when you apply it to multimodal data. Right? So I'll talk a little bit about what's on here before I start the video. It's a very short video. So this is a globe view. You can kind of tell we're not zoomed out very far at the beginning, but it works very similar to Google Earth. You can kind of grab the globe and move it around. These data points here are ships at sea. And then these little blue ones here are actually satellites. And if we were pulled out into the global view, you can sort of see it here. It shows them, out in space. So this is a management console. If you've ever used any kind of layered image software, you'll recognize something very similar. These show you the data layers that are visible currently. A lot of this data comes from our partners at URSA. A little shout out to URSA. They provide data for land, air, sea, and space. So I'll go ahead and start the video here. All right, so you see we'll zoom in on North America. There'll be a brief moment where there's a ton of data on the screen. That is aircraft in flight right there. We turned it off immediately because it obscures everything else in the video. The user's dragging the globe around here just to show you how smooth it is with all the data being displayed. This is running in a browser. You can sort of see the browser top at the top of the screen there. And so now we're seeing air control areas over stadiums. They're kind of hovering over different air control zones. And when they click on it, you'll see a little pop-up show up on the right-hand side of the screen. And that is one of our, what we call baseball cards, where you can drill into additional information about whatever you've clicked on through the interface. So yeah, there you go, the baseball card. You can see it's very smooth operation, works in multiple browsers. We're working to improve the mobile capability. It works well on tablets, but phones are a little challenging for obvious reasons. So that gives you a little idea, a little taste of how CommandCenter works and looks. Finally, I want to point out that we're ready for service. We're currently deployed on IL4 and IL6, which are security levels, cloud security levels with the DoD. We have a Platform 1 certificate to field, and that means that we are deployable across the DoD today. That's why we're able to leverage what we've done for another organization with what we're now doing for the Army. That should do it. Thank you.
Thank you, Michael. So I'll just spend a couple of minutes to talk about what we're hearing from our customers is they want to use multiple Snowball Edge devices and multiple Snow devices for running complex workloads or for highly available deployments. So to meet these requirements for our customers, what they can do is they can either deploy multiple Snow devices in a hyper-converged cluster, where each Snow device runs a little bit of compute, application, storage application, and networking. Or they can deploy disaggregated clusters, where in one cluster the Snow devices run compute and networking, and then there is another cluster of Snow devices for the storage applications. And when customers want to run these complex workloads or highly available workloads, they want to manage the entire application across all the Snow devices using a single management pane of glass, if you will. So for container workloads, they can use EKS Anywhere on Snow to manage their clusters with management cluster and worker nodes to expand and scale their clusters over time or replace devices as needed. For EC2, Army and VM workloads, again, you can manage multiple Snow devices using a single pane of glass to monitor, manage your EC2 instances, replace devices, scale your cluster by adding more nodes. You can do the same thing for storage, just a storage-only cluster in that disaggregated deployment use case. Today, you can go up to 15 nodes of Snowball Edge devices, and we'll expand that over time. And you can monitor, manage, replace, or scale your compute cluster. And the graphic also on the slide shows you an example of how customers could use these more complex multi-node Snow device cluster, if you will. This example shows 6 Snowball Edge devices installed on a single server rack. It's a 42U rack in this case. You've got redundant top-of-rack switches providing connectivity across all the Snowball Edge devices. You also have switch management. At the bottom of the graphic, you can see optional uninterrupted power supplies if you need it. And from the overall capability that the customer receives, it's in a total aggregate level of compute, vCPUs, storage, and networking. For example, customers can have up to 600 gigabits of networking throughput in this example. And of course, customers can deploy multiple server racks with this configuration. Thank you very much. Enjoy the rest of your show. Please do complete the session survey in your mobile app.